Alright, hello and welcome to CSCI 26. I am glad that you are here. So if you've never taken a class with me before, there's a reason the PowerPoint is not full screen right now. It's because I'll be switching around between a bunch of stuff. There's no use making it full screen. And then also I get much cooler pens this way, so obviously we're going to stay like this. So yeah, what's today going to be about? It's that standard first lecture. We'll get through it together. I'll talk a little bit about myself. We'll go through the class, like go to the syllabus. I'm sure that's what you most care about right now. And then we'll actually get into some CSCI 26 content. So yeah, lots of stuff to start us off. Let's get started. So a little bit about me. Hello, my name is Lawton Nichols. I use he, him pronouns, and I will respond to whatever you want to call me. I'll respond to Mr. Nichols, Dr. Nichols, Professor Nichols. But honestly, I'd prefer it if you just scratch all those off and call me by my first name. Please call me Lawton if you'd like. So a little bit about my background is I went to Fresno State for my undergrad. It's not too far away. And then I went to UC Santa Barbara for my master's and my PhD. So a little bit of everything. And I studied computer science for all my degrees. Other than teaching, I like to do normal human things. I like to dance. I like to play guitar. I like to hang out with my cat. This is Lonzo over here. He is named after, by the way, Alonzo Church, who was the PhD advisor to Alan Turing. So maybe you've not heard of Alonzo Church, but at least you've probably heard of Alan Turing by now. So yeah, I dedicated my firstborn son to computer science. And yeah, I just want to say, just to start us off, thank you in advance for putting up with me this semester. It's going to be a fun one, as usual. We live in this weird post-COVID time, and we're going to get through it all together, okay? So yeah, with that, let's talk about the class itself. Please read that syllabus. I'm going to go really fast because I don't like talking about this stuff either, just as much as you don't like listening to it. So yeah, let's get through this. So first things first, this class is going to be asynchronous, all right? Everything is asynchronous. I'll record every lecture and every lab, so there's nowhere for you to show up to. I'm a little bit sad. If you look at my schedule, there's a reason it's asynchronous. It's because there's way too many Monday, Wednesday holidays. This needs to be a Tuesday, Thursday class. My Tuesday, Thursday schedule is kind of booked. So that's the reason. So we're going to pretend this is a Tuesday, Thursday class. I'll just do the recordings before then. So here is the schedule that I'll try to keep, therefore. I'm going to have the first lecture video of the week up by Tuesday afternoon, the second lecture video of the week up by Thursday afternoon, and then if there's a lab that week, I'll give the introduction video for the lab up by the Friday afternoon. So that's going to be the schedule I'm going to try to stick to. I'm trying to do things a little bit earlier at the start of the semester, but probably don't get used to that. All right, so that's the schedule I'll try to keep. And because everything is asynchronous, there's no set time for this class, I'll give you a window to take your exams. To start and take them, I'll give you at least a 24-hour window, so you can take them at any time that is convenient for you. Okay, so I hope that works out. And the exams, we'll talk about them more when we get close to one, but they'll be timed, they'll be on Canvas, and a timer will start ticking down once you begin it. So just keep that in mind. That's how it's going to work. As far as expectations go, you can kind of breathe a sigh of relief because CSCI 41 is supposed to be the hardest class, right? It's the weeder class, and you got through it because you're here, all right? CSCI 26, though, it's a completely different kind of computer science, I would say. It's a different topic. It's more math. And so I wouldn't say this one's super easy, but technically it's not the hardest class we have. So that's kind of nice. So just be ready to learn a bunch of new stuff that you've never seen before. It's a weird kind of math that we're going to learn, okay? And then we'll also talk about some stuff we've already learned in more depth under the lens of mathematics, all right? So we'll get there. In general, I think this class is a little bit more tedious than it is hard. You just have to do the work. If you do the work, you will do well, all right? You're going to have to read all of the textbook chapters to do well as well, okay? Just prepare for that mentally, all right? We're going to have to learn how to write proofs. Maybe you remember that from a geometry class. There's so much more to that, sadly. It takes a lot of writing. Some of us don't like that, but we will get through it all together, okay? And so this class is it's the one computer science class that's homework based. You're going to be writing homework answers. You're not going to be writing up code a lot of the time. This is more of a math class, okay? but I promise, this class is going to make the rest of your computer science life a whole lot easier. Okay, so that's where we're going. Hopefully I'm trying to motivate you a little bit right now, and it's working out. But again, this is a 4-unit class. I think you know the rule by now, right? If you have a 4-unit class, that means you're going to be spending 4 hours in class listening to me talk or like explain labs, and then you're going to double that, right? That means you're going to spend 8 hours outside of class doing work, and that's what it means to take a 4-unit class. Okay, so just mentally prepare that you will be hitting that rule. Like, you will be doing those 12 hours of work some weeks. But yeah, I'm not trying to scare you away or anything. I just want to make sure you understand the workload and you can plan accordingly. I'm going to be here as much as humanly possible to help you, and your peers will be there for you as well. So yeah, that's expectations. Moving on, let's talk about the technology loan program. So if you need like a better internet connection, a better laptop to do your work in this class, the school is renting those out to you. Just go to the library, fill out a form on our resources page on Canvas. It's on our modules page. So hopefully you've noticed that like you got to go to the modules page to unlock all these guys, because I force you to look at everything. But this is the student resources page. You can look into that if you need this. Please take advantage of what the library has. They're even like renting out graphing calculators if you need that for another class or something. So they got a lot of cool stuff. Look into it if you need it, so that you can succeed. And then yeah, let's go to the place you probably want me to go right now. Let's go to the syllabus. So that's this one. You can also get to it on the home page. But here is the link, and I think I want to open it in a different way. Let me mess with this. There we go. So here is our syllabus. It should be pretty accurate right now. I'm not gonna, hopefully don't have to change it much, but let's scroll down to the place that you probably want me to go. So the grading section. All right, these are all the different kinds of assignments you're gonna have in this class. You're gonna have homeworks, written homeworks like a math class, programming assignments, I'll call those labs. You're gonna have those assigned at least every couple weeks. Homeworks are going to be more numerous than programming assignments for once. This is like the one computer science class where the homeworks are so much more important than the labs, finally. So yeah, that's that, and like homeworks will be worth 25% of your grade, and then 15% of your grade will be from the lab. So the homeworks are more important. All right. We'll be having 2 midterms. So this is an 18-week class, so like week 6 is a third of the way through the class. Week 12 is 2/3 of the way through the class. And then the final will be at the very end, 3/3 of the way. So that's when those will be. And the 2 midterms will both be worth 15% of your grade. And, okay, what else? I'll also be giving you little check-in surveys. You should see that one. The first one already available. It's just me asking you to psychoanalyze yourself each week. It's a very easy way to get 5% of your grade, so please remember to do those. I'll also be using those for attendance, so I'll talk about that later. What else? And then a final, that'll be worth 15% of your grade, and then your textbook homework reading assignments, like I'm going to ask you to read chapters out of your textbook, that'll be worth 10% of your grade. Okay, so that's the grading setup. I will also make extra credit available throughout the semester, usually during exam times. But here's a new rule starting this semester. I will give you 0.5% extra credit on your final grade for going to any ACM club workshop. So see the Discord for our class. There should be a sign-up link to get to the ACM club's Discord server, and they will be in their workshops channel announcing a bunch of workshops, and I will give you extra credit for each one you attend. There's like a sign-in sheet every time you go. So do that if you would like. I also have my own extra credit assignments too. And I will give you at most 10% extra credit on top of your final grade at the end of the semester. So don't like do all my assignments and then also go to every ACM club workshop. I'll cut you off at 10%, okay? That's 1 letter grade. So that's that. And then, yeah, the check-in surveys are very important. That is right here. This one is released. Let's see if I can zoom in a little bit. So just like fill out these questions every week and tell me like what you're struggling on. Eventually, that's what I'm going to ask. Like, what are you struggling on this week? As long as you do those, I'll give you credit, like as long as you write something. And that just helps me understand where you are, and then also it's going to be the way I'm required to take attendance, even though this is an asynchronous class. This is going to be the way that I take attendance. I'll have to drop you if you don't do it. So please do at least the first one, okay? So that's that. And then finally, I think I've gone through everything but the final exam date. So let's go to that. Scrolling down, few holidays, and here's when I'm going to have the final exam. Again, there's no set time for this class, so the finals week starts on May 13th, and so I'm going to give you the final exam. I'm going to let you take it between sometime on the Monday through the Tuesday of finals week, a 24-hour range of time at least. All right, so that's my plan. That's when you're going to be able to take this test. All right, again, it'll be timed. It'll be like a 2-hour exam once you click start, just like a midterm, but that's when the final will be. All right, so mentally prepare for that. And yeah, that is the syllabus in a nutshell. Please, again, yell at me, ask me questions on Discord if you have any questions about anything at all. I do have to go a bit fast so that we can get to the good stuff. So again, homeworks are pretty important in this class. This is like a math class. I am not going to grade your homework super harshly because it's like the first time you're practicing these things. That's what a test is for, right? So here's my promise to you. If you get at least 70% of the questions correct on your homeworks, and you attempt every single problem, you give it a good try, all right, then I'm going to give you 100% on your homeworks, all right? I think that it seems fair to me. So that's the way I'm going to grade your homeworks. Please write nicely. If you have bad handwriting, I will mark you down for that, okay? So that's homeworks. I'll release the first one. I'll talk about it later. But that's that. Another important thing in this class is due dates. I do things differently to most professors, and there's a reason for it. So please prepare for every assignment in this class, except for the check-in surveys, which will be due at 5:30. Every other assignment in this class is going to be due at 5 p.m. on the day that it's due, all right? And the reason for that, I think you know by now, like computer science, so many things go wrong, right? This makes sure that I am awake whenever something goes wrong and I can help you, all right? I'll be on Discord. I'll be in office hours at this time when important things are due, and so then I'll be able to get the problem resolved, and then you can go to sleep, and we can all have weekends and things, okay? So that's the idea of my due dates rules, so please prepare for that. I do have some exceptions, though. If any of these apply to you, please contact me, and I'll make sure you get these extensions. So I give extensions to some of my assignments for my working students. So if you work at least 20 hours a week, so half-time, school does not count. If you're taking 20 units, that's your fault, right? I will extend your due dates an extra 7 hours, all right? So you really will have your due dates at midnight if you work at least half-time. So contact me if that applies to you. And then if you work at least full-time, at least 40 hours per week, or you do something that is the equivalent of a full-time job, like you care for a child, something like that. So if that applies to you, if you do that, then I will extend your due dates an extra 15 hours, all right? So you can either stay up late or wake up early, and you can get the assignment in, and I hope we all agree that the people who these exceptions apply to deserve the extra time. So that seems fair to me. So let me know if any of those apply to you, and I'll make sure that your extensions are set in Canvas. Okay, so that's that. I'm also pretty lenient about late submissions, so I'm going to accept late homework reading assignments, late labs, and late check-in surveys up to the last day of instruction. So like if you miss a whole week, like just do it later. It'll be fine. But I do impose a pretty harsh penalty. That's the trade-off, right? You're going to get only half credit the second something's late, so that's your incentive to do it on time. And the one thing that I don't see is when your Zybooks readings, like your textbook readings, are turned in late. Unfortunately, Zybooks doesn't tell me, and it'll mark it as a 0 on Canvas. So just let me know when you do that, and I will make sure to give you your credit back. And then the one thing I'm not allowing late is homework submissions, because that takes forever to grade. And also I'm releasing the answers after every due date. So it makes no sense to let you do that late at that point. Okay, so that's that. That's my late submission rules. What else? I'll drop a few lowest scores because I know life happens during the semester. I'm going to drop your lowest 3 homeworks, your lowest 3 textbook readings. We'll talk about the textbook. We'll go there soon. And then your lowest 2 labs. Those are your programming assignments, remember. Okay? And then hopefully you're not trying to write everything down. This is a computer science class. I'm going to give you all the code that I write and all the slides annotated and everything on Canvas. Okay? So that's that. And so you don't have to feel like you have to write everything down. Also, this is recorded anyway. So Let's see, what else? Let's talk about the class server a little bit. I'll talk about this more during your first lab introduction video, but your programming assignments in this class, they're called labs. They'll be done on our class server, which is an Ubuntu Linux server that I've made for us. And you're going to turn it in using a turn-in command on our class server. And I've made you all accounts. I'll talk about that later. Let me know if you added the class late and your login that should work doesn't work. I'll make sure it works. And then also, don't use some IDE like Visual Studio Code to connect to the server before you talk to me, because it'll lock you out. Okay, so that's that. Yeah, let's talk about the textbook now. So your textbook is a very magical thing. It's not physical, it's virtual, and they've made it very nice and interactive. So I'm going to assign you reading assignments, and that's going to require you to complete a bunch of little mini tasks inside of every chapter. It's really cool. So this is something you have to buy. I promise it's worth it. All right. It's really going to help you learn that interactive stuff. It's great, especially towards the later chapters. You can buy it in one of two ways. You can go to the bookstore and they'll give you a little code, or you can buy it directly from the zyBooks website. I encourage you to do it this way because I've heard horror stories of the bookstore waiting too long and you have to receive a physical slip with a code on it in the mail for no good reason. So to activate it, regardless of the way you buy it, to activate the book, just go to the first link. There's a link in the first assignments. Here's the chapter 1 assignment that is released. You go there, and then it'll say load chapter 1 in a new window. If you click that, it will take you to zyBooks. It'll take you there, and then also, once you buy it, it'll take you to the actual assignment. But before you buy it, if you buy it this way, it'll either ask you to type in your code, and there'll be a spot to give in your code that you got from the bookstore, or there'll be a place to put your credit card information or something. So this is the first assignment, though. Eventually you'll get to here, I promise. All right. Every other assignment is up, by the way. If you scroll to the bottom of your modules, it's very, very far down for me, but it shouldn't be too far down for you. Every assignment is here, so if you have no life and you feel like it, please get started early. That will only help you. But yeah, that is your zyBook, and here is the first chapter. You can kind of see it's got some options. This is not very cool and interactive, but here's an animation. You'll have to watch this, and it will track that you watched it completely. Sometimes it asks you to do extra things as the animation is playing. It's really, really cool and useful. So this is your first section of your first assignment. To get to the book itself, you can zoom out to here, and you can see all your assignments like this. The first one will be selected when you go to it, but here are all your assignments. If you click one, it shows you all the subsections that I ask you to read, and you can track your grade this way and make sure you're getting the full credit. Okay, so yeah, just remember this assignments tab is going to tell you exactly what to do, and then the due date is the one that's on Canvas. Don't trust the due date on here. I just had to make it the last day of the semester so that you can turn things in late. All right, so that's your book, and I hope you like it. So that's that one. So just click the link in the first assignment, and it will take you to it to either activate it or buy it, and then after that it'll just take you to the book. So there's that. That's your textbook. For communication with me and your peers, I would encourage you to use Discord. There is a link to join our Discord server for the class on Canvas. Please go to that. And I encourage you to use Discord as much as humanly possible for your questions. Ask public questions in our CSCI 26 channel so that your peers can help you. What I don't want you to do is ask a bunch of public questions that share answers or lots of code, because that would give things away that I don't want given away. Little pieces is fine, but use your judgment, please. Don't share an entire answer. That's a little too much. But yeah, here is our Discord server. When you join it, only the welcome channel and the guide channel will be available. Just scroll up to the top of the welcome channel, click the 100 emoji to add the general channel, and then click the fox to join the CSCI 26 channel. And so here's where you will be asking me questions, and this is where you can interact with the other students in the class. And so that's that. Hopefully that is fun. If you have a question, you need really to show somebody some code, show it to me, please. And so you can always privately ask me questions in a direct message. So if you want to DM me, you can right click on me and then you should be able to message me. I can't message myself because I am me, but like if I wanted to message Max here, like there's a message button, and that would take you to somewhere useful. All right, so I encourage you very, very strongly to use Discord to contact me instead of email. I think you can imagine that every professor's email is disgusting, and Discord makes it really easy for me to see when somebody sent me something. So I'll get back to you much sooner if you use Discord, I promise. So please use that for your questions, either privately to me or publicly to the group of students in the class. And then also, if you need help, I also encourage you heavily to come to office hours. So my office hours will be in person if you'd like to show up on campus if you want to. If you're already there, they will also be on Zoom. Every office hour will also be like simulcasted on Zoom. So if you go here, my office hours page shows you my schedule. This might change, so just check it every time. Like the green things are when I plan to have my office hours at least. And then to join, like you can either show up on Monday at this time in my office, or you can go on Zoom to my office hours Zoom link. All right, so you click that one or this one, they're the same link, and it will take you to where you need to go, and I'll be there to help you. All right, so yeah, please come to office hours. There's also the tutorial center on campus. If you haven't been there, I highly encourage you to go. They do online tutoring too. I think finally, before we get into like more CSCI 26 specific stuff, I just want to talk about like getting help, right? Because there are a bunch of ways for you to get help, and I encourage you to use those ways, all right? You are going to get stuck in this class. I'm sure you've gotten stuck before in a computer science class. I highly, highly encourage you to ask for help, all right? So let's pick an amount of time, all right? Let's say that if you've been stuck for 30 minutes on a problem and you're just scratching your head, you have no clue what to do next, then please, that's when you should ask for help, all right? Let's do that. There is no virtue in staring at your screen for 2 hours. That's the phrase I like to use every semester. I know because I worked like that when I was an undergrad, and it was not fun, all right? So please get help when you need it. It is my job to get you over your current hurdle, right? Get you over whatever is troubling you and on to the next thing that you can also scratch your head on for 30 minutes about, all right? Though you will find, I think, getting stuck for 29 minutes is exactly what I want to have happen, right? That's how you learn in computer science. So that'll happen a lot. Like 25 minutes later, after confusion sets in, you have like a flash of genius, and that's how you advance your knowledge in this class and in computer science usually. So yeah, please ask for help if you get stuck. I'm here to help you. Your peers want to help you. The tutorial center people want to help you. We're all here for you. All right? Before we get into the final content, I want to talk to you about a place called the class website, which you will only really be using for one purpose because this is an asynchronous class. But the link to it is on our home page. It's this class website link. It's www.lottensclass.com. And here it is. Here I'm logged in as myself, but you'll only see these things, these apps right here, not because you're not an admin. But you can change your password up here. But you will be going to lab grades a lot, all right? That's where you will be living. It will show the grades for your labs done on the class server. They will get copied here, and you can see them in a pretty way, all right? So I've made you an account on here. Please let me know if if it's not working for you. But I've made you an account on here, and I've also made you an account on the class server. So they're two separate places. I want to say that. The class website, this place, has one account, and the class server has another account. The confusing thing to you right now might be is probably that the username is the same. All right, right now on the class server and the class website, you have the same username and default password. It's both your last name underscore your student ID duplicated. That's your username and password on the class website and the class server. When you change one password, it does not change the other. So like changing your password on the class website does not change your password on the class server. I just want to make that clear. Okay. That is confusing to a lot of people, all right? But they have the same username and default password, all right? So it's here, www.lottensclass.com. Your username and password are both right now your last name, all lowercase, underscore your student ID, all right? So if this was your last name and your student ID, this would be your username and password for the class website and also the class server. And if this was your last name, like you had accent marks and hyphens, you're going to get rid of all of those. And this was your student ID, this would become your username and your password right now, all right, on the class website, and then also the class server, which I'll talk more about during the first lab. So that's that. Let me quit out of Discord before I run out of RAM. And yeah, just let me know if like it's not working, because maybe you added the class late or I messed up somehow. And yeah, that's that. So I think we made it through the logistics section of the class. So I did go lightning fast. Let me know if you have any questions. Ask me on Discord. All right. So we can finally talk about CSCI 26 now. All right, we're ready. So here we go. This class is its technical title is called Discrete Mathematics. All right, and what that is, if you go and look that up somewhere, it's the study of mathematical structures that are countable or otherwise distinct and separable. All right, so the easiest way for me to describe the difference to you is like, this is not discrete math. This is like calculus, graphing normal things, right? Wavy, curvy things, like there you can zoom in infinitely. That is not discrete, right? It's not countable, it's not distinct, all right? In discrete math, we look at stuff kind of like this. Like this is how we would view the graph of something. Like we'd view it in discrete little chunks, something like that. Like, boop, it goes up that much, goes up that much. And like we look at it like 0.1 distance apart or something. That's kind of the difference between discrete mathematics and like continuous mathematics or something. Trees, for example, that's a good example from CSCI 41. Like trees are a discrete structure in discrete mathematics, right? Because you can't have like 2.5 tree nodes. That makes no sense. You can only count them in whole numbers. So that's kind of where we're going, all right? That's what we're going to study. And so here are a bunch of topics that you may have seen before that we're going to hit hard this semester. We're going to talk about logic, writing proofs, number theory, how to count stuff, how to do probability things. You've seen this before in previous math classes, I'm sure. We're just going to hit it harder or look at it from a computer science lens. And then like a sneak preview is this little guy. This is called a graph, all right? It is a relative of trees in that there is no root anymore. It's like you can have you can go in a bunch of different ways. Like you can have potentially 3 ways out of the 5 node, for example. There's no concept of direction. Or sometimes there is, like you can both go this way and this way along these edges, etc., etc. This is a graph. It's kind of like a tree, but it's a bit less strict. You can have loops. It's really cool. So we'll get to that later, but that's one thing that we will study, for example. So that's discrete math in a nutshell. We're going to talk about that a lot. That is the title of the class. Let me also try and motivate, like, why would you want to learn all this stuff? Like, logic's going to be the first thing that we're going to learn. Like, why would you care? All right? So logic is the study of formal reasoning, which sounds very bland and disgusting and boring. So let me try and motivate it to you as best as I can. So I'm going to prove to you that learning how to think logically is very, very useful. Probably you've technically learned a little bit as you've been writing bigger and bigger programs. So here's a little exercise for you. Maybe you try pausing the video. I know I give this exercise to like my CSCI 40 students, but you are ready to answer this now. This is going to help you learn to think logically and help me motivate why it's important. So what does it mean for, like, if you have a vector, what does it mean that that vector is sorted? All right, can you explain that to me? Like, what should the definition of being sorted mean? Like, pretend like I'm an alien and I've never heard the word sorted before. How would you just define the word sorted to me in the context of like an array or a vector? Like an array is sorted. How would you tell that to me? Like, how would you describe that without using the word sorted? So the goal for this class is kind of like to like be able to logically specify exactly what it means to have a sorted vector. All right. So like, for example, so again, maybe think about it as I'm doing my explanations, but like, here's an example vector. This is sorted, right? 1, 5, 9, 42. Why is it sorted? Here's another vector. This one's not going to be sorted. Let's say it's got like 8, 6, 7, 5, and then 20. Why is this one not sorted, but the first one's sorted? All right, see if you can define this as precisely as possible, as that's important too. And then, well, here's the idea, right? This is sorted because, like, let's see. The numbers are going this way. As the indices increase, the numbers are getting bigger, right? And this one is not doing that. It's like going up and down. We don't like that. That's no fun. So that's not sorted. That's not sorted, but this one is. Can you make that more precise, maybe? maybe you'll be like, it's always getting bigger. But then I would claim, isn't this vector also sorted? 1, 1, 2, 3. That's sorted too, isn't it? So it's not always getting bigger. It doesn't have to always get bigger. It's more like a stair step, right? It could get bigger or stay the same for a little while. That's still sorted, isn't it? All right. And so if you wanted to logically specify very precisely and very cleanly what it means to have a sorted vector, here's one way you can do it. All right. I'll describe it to you. It's kind of like things are getting bigger or staying the same. How would you write that in math? Here's how you would write it. So we have to come up with indices. Let I and j, just imaginary things, let I and j be indices in this vector that you're claiming is sorted. Be indices in this vector v that you're trying to talk about. And then also, let I be smaller than j. So like, this could be I over here, this could be j. Or j could be over here, as long as it's not before I, right? This could be I, this could be j. Right? V is sorted, right? V is sorted when every possibility for I and j, where I is less than j, V is sorted if and only if, there's a symbol that means if and only if V of I is less than or equal to V of j. That is how you define sortedness. So pick some random I and j and try every possible one where I is less than j, where those are indices in your vector. Like this is I and this is j maybe now, and then maybe this is I and this is j later. Try every possibility for I and j. V is sorted, your vector is sorted when, for every one of those i's and j's, the value at index I is less than or equal to the value at index j, for every possibility where I is less than j. That means it's sorted. Does that make sense to you? So that's a bit complicated. We'll get there in due time, but this is very clean and precise, and to learn how to write that way and to think that way will make you a better programmer, I think. Okay? So that's the point. That's my motivating you. Then proofs are the next topic after logic. So let me try to prove to you that proofs and learning them is a good idea. So here's a silly example. All right, suppose that we want to sum up the numbers from 1 to n. I'm sure you know how to write an algorithm to do that, right? So like let's say, I don't know, n is 5. Somebody gives you n, the user gives you n as 5, and so you want to give back in your function or whatever 1 plus 2 plus 3 plus 4 plus 5. How would you prove beyond a shadow of a doubt that your code really does give back this value? Like the sum variable is going to hold the right answer for n being 5. How would you prove that, right? So how would you know for sure that the code that you wrote does exactly what you want? Well, one way to do it, a very good way, is to write a proof that guarantees that by the time your code gets here, the sum variable's value holds exactly 1 plus 2 plus 3 all the way to whatever n was. Could be anything. And so if it was 5, it would work. If it was 10, it would work. Isn't that cool? And this code, by the way, is wrong. Do you see why? This is subtly incorrect, and this is the kind of thing that you need to prove. You'll notice in a proof, and you'll fix it, and it'll help you be a better programmer. Right? So this code's wrong. Why? Because it doesn't actually get up to n. Right? So let's talk about that. All right. So here's one way to prove that this loop, if it were correct, that it was doing the right thing. All right. It has to do with what's called an invariant, all right? And that comes from the words precondition and postconditions as well, which are things that we learned about in CSCI 40. If you took my class, those words were in our textbook, right? So a precondition is just something, a logical statement. That's why we learn logic before proofs. A precondition is something that's true before your statement gets executed. Like before here, what's true from the point of view of this? So like from the point of view of I, this line right here, something true before that line is called a precondition, and then something true after that line would be called a postcondition. All right. Postcondition is what's true after the statement gets executed. So like, all right, what's a precondition for right before this line? What's true about the world, about the program? Well, sum is definitely going to hold 0 before we hit this line, right? That's a precondition. That's a valid precondition. And then after this line, a postcondition for this line, int I equals 1. Well, sum hasn't changed. Sum's still 0, and I is a variable that exists now, and it holds 1. So that's a post-condition for that line, all right? An invariant is like a precondition and a postcondition at the same time. It's something that's always true. It doesn't vary, all right? Invariant. That's something that's always true, and a loop needs invariants to prove things about loops, because loops can repeat their bodies one or more or infinitely many times, right? So you want something that's always true regardless of how many times you've gone through the loop, all right? So a loop invariant is something that's true after some number of executions. So the way that you rate that is after, come up with a variable name, after k executions of the loop for all values of k that are possible. 0 executions, 1 execution, 2 executions, right? Again, I don't expect you to understand what I'm doing right now, all right? We're going to get there, but this is useful knowledge. So here's a loop invariant, something that's true after this loop always, and even before it, no matter how many times you run the body. What's it doing? Well, it's adding whatever i's value is into sum and incrementing it. So like after this loop is done, like what's true about this always? It's sum has a value in terms of I, right? After I many iterations, sum holds 1 plus 2 plus all the way to I minus 1, all right? See if you can convince yourself that that's true. So that's what's going on, and here is how you would prove that this loop does the right thing and actually gives you back the correct sum, which is like what we want right here, right? Our post condition after everything is done is that sum holds all the values up to n. That's what we'd like. So this is our loop invariant. Let's prove that this is a correct loop invariant. We have to prove that it works before we get anywhere. So let's see, let me put my scratch work on the side here. We have to prove that this works before we get anywhere. So like before we've done anything, before we even hit this loop, is this true? Is sum equal to 1 plus 2 plus all the way to I minus 1? Well, if I minus 1 is 0, all the way from 1 to 0, that's nothing, that's 0. So yeah, it works after one iteration. And then does it work after an arbitrary number of iterations? So the idea is, like, right now, sum holds this. Sum holds, like, we're about to execute the body again. We know that this is true before. We can assume that it was. Sum is equal to 1 plus 2 plus all the way to I minus 1. And then we run the body. What is true about sum after that, right? So the new sum after the body gets run, it's like, let's call it sum prime. It equals, well, what it was before, because we're adding to it, right? Plus I. Sum prime is equal to 1 plus 2 plus ... plus I minus 1 plus another I, because we just added it there. And then we're also going to change I, so after the loop's done, I is now changed to like I prime is whatever I was before, plus 1. And so, is this true about the new values, about sum prime and I prime? That's the question. Is that true right now? Yeah, I think so. Do you see it? Because what is I but I prime minus 1? Yeah, isn't that fun? That's I prime minus 1, and that's the hand-wavy way of knowing that sum holds the right value even after an iteration. So it's always staying in lockstep, and this is always true, regardless of the values of sum and I and how many times you've gone through this loop. Does that make sense? So, by the time you break out of this loop, what is true here? What do you know about? What is true? What's the post-condition of this while loop? Well, if this while loop ever stops, right, I better have been greater than or equal to n, right? Does that make sense? So what do you know once this loop is done, because I is increasing by 1 and starting at 1? We know that I must be equal to n. Do you see how I can deduce that? If this loop ever stops, I better be equal to n now. That's what broke me out of this loop, all right? So what does that mean? If this is the invariant about sum versus I, sum is equal to, if I is n, sum is equal to 1 plus 2 plus all the way to n minus 1, and that wasn't far enough. Do you see that? So there's our error. Do you see that it should have been less than or equal to now? And in proving that, we notice it. So how do we fix that? Just make sure, like put a little equal sign there. And now, what will break us out of this loop if I is greater than n, strictly? So that means it'll be n plus 1 that stopped the loop. Now that's what I is. And using the invariant, 1 plus 2 all the way to n plus 1 minus 1, that gives us plus another n, and that means sum is giving us back the right answer, right? So that's a simple little example, but you see how complicated it is there even. Like that's what you have to do to prove beyond a shadow of a doubt that your program's doing the right thing. That's one way to do it. okay? Do you see how cool that is and how that's going to make you a better computer scientist? It's going to make you much better at reasoning about your code because you have to think so much about it, okay? So I promise it's worth taking this class and putting in the time, okay? So with that, let's keep on trucking. I want to teach you a new programming language just for fun. And then we'll talk about logic and all that stuff. Like all this stuff, I do not expect you to understand right now, okay? This will also be new and make your brain hurt a little bit. But after this, we're going to go to like the original, what was meant to be the first lecture, okay? So I want to teach you, before we get there, about a programming language called Racket, which looks nothing like C++, all right? In this class, you are required to write C++, but there is a loophole and I am not, all right? So I'm going to expand your horizons by teaching you a brand new programming language that looks really weird, all right? So I'm going to use a language called Racket. It's a functional language, and it is a dialect of an older language called Scheme, which was taught by MIT for years in their Intro to Programming class. So you could have learned this first if you were a child of the 80s or early 90s. And Scheme, by the way, is a dialect of a language called Lisp, which is one of the original programming languages ever. So it's been around for so long, and it's really cool. So Lisp, by the way, it's an acronym. It stands for List Processing. So everything is based around the idea of this data structure called a list. Oops. And I'm not going to test you on Racket. That would be evil. But you're going to figure it out as I write some code for you. All right. Do try to read the tutorial in the optional readings page. All right. But I have a bunch of examples. And before we get there, here's kind of what Racket is all about. So instead of calling a function like this, foo bar 42, this is what it looks like in Racket. You put the parentheses first. You say the name of the function, I'm calling foo, and then you give the arguments and you space separate them with bar and 42, then you close the parentheses. So that looks really weird, right? This is how Lisp programs in general look. So Racket and Scheme and Lisp, they're all like this, which is really cool. All right, so that's Racket, and let me show some Racket to you. So here's the first file, hello.rkt is the default Racket file name. The first line just says, I really want to use the full language, and then this is the one line that actually does anything. So it's called displayln, and then you give it a string, you're calling that function, and it looks weird, and that's going to print hello world. So to run it, you use the Racket program, the Racket command, then you give the name of the file. So hello.rkt, and it'll run everything in the file. Run all the lines. And so there it goes, printing hello world for us. Isn't that fun? Okay, before we get to the next one, Racket is big on parentheses, as you know. So you are allowed to use those parentheses, angle brackets, no, square, these are called square brackets. Those function also as parentheses, you can swap them in. And also curly braces function as just normal parentheses, as long as you like close it with the same kind. These are all equivalent to parentheses in the Racket language. It's really weird and really cool. But usually people use different ones to differentiate stuff. So here's the other file. So here's some examples. There's no main function, it just starts running code. Here's how some things work. All right? Define makes a variable or a function. So define pi to hold 3.14. That makes a variable. Here's a function definition. Define the function print from 1 to up to n. And here's the body. Right? Do you see how there's a bunch of weird parentheses? Sometimes there's this. This is a conditional statement, con for conditional. Don't let the parentheses fool you, by the way. To really understand this, go off of the indentation, right? I've made the indentation really pretty. Just don't look at the parentheses. That's how you can save yourself from getting confused. All right, so try your best to understand this. That's really cool. This is a recursive function, by the way, because Racket is all about that, and we care a lot about that in this class specifically. So how do you print from 1 to n? Well, base case, if n is 1, conditional, if n is 1, then just print the number 1, because printing from 1 to 1, you just do it in one line. Otherwise, if that wasn't true, then you have two things to do. You have to recursively print from 1 to n minus 1. There's the recursive call. And then print your n after that. So here's how you can print from 1 to 5, and that's me calling that. All right, so let's, what's the best way for me to comment out all of this? Let's just do it disgustingly. That'll work. So there's print from 1 to 5, and we should see printed now when I run cool stuff to RKT 1 through 5 printed out. All right, and then I'll uncomment everything again. To make structs of a bunch of things together in one place, you use the struct. Think of it as a function, maybe. Think of it as like a keyword. So struct, I'm going to make a struct that holds two-dimensional point values. And then I want the fields of my struct to be x and y. So this makes a struct called 2D point, and it has two fields called x and y. And it'll make some helper functions for us. It'll make like getters, 2D point get the x, 2D point get the y, and check if the thing was a 2D point that you gave to this function. So names are kind of cool too. Like you can have dashes in your function names, and then also question marks, because really it's just anything around parentheses is fair game. That's pretty cool. So yeah, here's me making a point. Define P to be a 2D point holding 5 and 7, and then I can print that out. Let's just run all this, and I'll walk you through it. So here's me printing the X part of that. That'll print the 5 right there. You can print the whole thing if you want to. Racket is built around lists, by the way. So, and all Lisps are, by the way. So that means I can make lists very easily in this language. It's kind of like based on them. So lists are like the array of the Racket language. So here's me making an L1 variable, and here's how you can build a list. List 1, 2, 3. Just say that. There's shorthand for that as well. It's the quote character. So this quote 1, 2, 3 is the same as list 1, 2, 3. Just a little bit faster. And so here's me printing L1, 1, 2, 3. Let's see, what else? This is a functional language. So functional languages are all about like passing around functions as arguments to other functions. If you've learned a little bit of JavaScript, maybe you've seen that before. It's just really fun, and there's a function called map. That's probably the easiest higher order function. And what it does is it applies some other smaller function to every element of a list. So here is a simple function called add2, and it takes whatever it was given, it's n, and it adds 2 to it, right? So if you pass it 1, it'll give you 3. If you pass it 5, it'll give you 7. So let's map the add2 function to the list L1. Here's the list L1 again. It's 1, 2, 3, right? So mapping add2 to it and printing the result, do you see how that's going to give you 3, 4, 5? Because it's going to take the 1, add 2. Take the 2, add 2. Take the 3, add 2. Isn't that fun? That's the map function. You're using another function as an argument to some bigger function, and it will apply it to every element of a list. Isn't that really fun? So that's very powerful. It might be very confusing to you right now, but I promise it's powerful. It was kind of dumb to make a function that we just used once, though. There's a way to get around that. Have you heard of lambdas before? I teach that in my 41 class. Have you heard of those? A lambda is a function without a name. It's an anonymous function. So here's the same thing, but using lambdas instead. Like we don't have to make a separate add2 function because we're just going to use it once. So map, and then between here, this defines a function in line. It's like, all right, make a function on the fly with no name. Lambda just means make a function with no name. It has one argument called x, and it adds 2 to that x. So here is me passing a function as an argument to map. Map the function that adds 2 to its argument, and then give L1, and again, it does the same thing. So look into that if you're interested. Very, very cool. C++ has lambdas. Very useful. And then another fun one is filter. Filter applies a function to every element of a list, but this function returns true or false. It applies a function that returns true or false, and it keeps the things that return true. It extracts things. Filter extracts the elements of a list where the function that you passed along returns true for those elements. Right? So filter, here's a function that gives back true when its argument is greater than 1, greater than sign as a function x1. That's how you test for greater than 1. Similar to this, right? So this is a function that gives back true when its values are greater than 1. And so let's filter all of the values bigger than 1 out of L2. So what was L2? That was 1, 2, 3 again. So filter all the values that are bigger than 1. That produces the list 2, 3. Isn't that fun? It's probably mind-blowing. Again, I don't expect you to understand anything that I talked about so far. It's just starting to poison your mind and get you ready for the class. All right. So with that, I'm going to make a new video because I want to try and make these work across semesters. And so I will see you there, and we're going to learn about logic now finally. But fun stuff already.